Have you noticed that every word in an AI news article looks familiar, but the whole thing still reads like you don't understand? Like the words LLM, token, transformer, RAG, SFT, LLTHF, MOE, a single article, so using this word can throw more than 10 abbreviations at you. And today I'm going to explain 20 of the most common AI terms and place them inside one complete process so you can understand very naturally. I've also organized them into a mind map, so save it. You can come back whenever you run to an unfamiliar term. So let's begin with LM, which stands for Large Language Model. ChatGPT, Claude, and DeepSeek all belong to this category. The question or instruction you enter is called prompt. Before the model processes that prompt, it passes through the tokenizer. The tokenizer divides the text into smaller units called tokens. A token might be a Chinese character, an English word, or only part of the word. It is the currency of the model use, and each token is also assigned to a numerical label called a token ID, which allows the model to process it mathematically using vectors in math terms. The main architecture used to process this token is called the transformer. One of the important mechanisms is called self-attention. Self-attention in transformer helps the model to determine which piece of the information in the context are related. For example, when you write Apple has released a new model, the surrounding words help the model decide whether Apple refers to the fruit or the technology company. The context window is the amount of information a model can process at one time. A larger window means the model can house more material. It does not mean the model will automatically identify the most important parts. Next is RAG, or Retrieval Augmented Generation. Its logic is simple: search first, answer second before generating a response. The system retrieves the relevant information from websites, databases, or private knowledge base. It then places information into the model's context. RAG is commonly used when the model needs recent information, access to internal documents, or stronger protection against hallucinations. A parameter is one of the many adjustable numerical values inside a model. So together, those parameters, influence how model interprets information and generates its answer. A dense model activates most of the parameter for each request. A sparse model activates only a relevant portion of them. MOE stands for a mixture of expert, is the common terms and types of sparse model. Major company with technical, legal, and financial departments. When a new problem arrives, company, which is a system, calls in and only the departments related to that problem. There is no reason to invite everyone to every meeting. So that's an analogy of how the term works. Next one is how this model trained. The first stage is called pre-training. The model reads a huge amount of text and learns patterns in language and knowledge. When data travels into models and produces a prediction. That process is called forward propagation. The difference between a prediction and its desired result is called loss. The model then uses that error to adjust the parameter from the output side back to the network. It is called backpropagation. After this process has been repeated many times, the result is a base model. It can generate and continue text, but it may still be poor at following instructions. The next term is SFT, or supervised fine-tuning. Developers prepare high-quality examples, questions, and answers. The model studies those examples and learns how to respond to instructions in an expected format. After that, it comes RLHF, reinforcement learning from human feedback. Human compares several answers and ranks them. The system turns this performance into scoring rule and the model continues adjusting itself according to those scores. This helps its answer better match the person and human's expectations. Maybe we said learning a technology is not about sounding professional. It helps you to identify where the problem is happening when the answer misses the task inspect the prompt and text when the information is outdated. Consider when a model cannot run on your computer, those smaller and more efficient model fine-tuning only makes sense because this makes the model perform better in a specific situation or condition when the text is stable and you give enough reliable data. Useful AI literacy means knowing what the technology involves and what it still cannot solve. So that's it. I'm Xuran. Thanks for watching the video. If you like, subscribe, and let's see you next time about teaching more new updated AI information. Thank you very much.